Hi everybody. A few days ago I made a little video presentation describing how the virus that causes COVID-19 gets into our cells and causes damage. And this has raised a few questions with people, and I'm going to try and answer these in this little video here. I'd point out that everything I'm going to talk about is my knowledge as of 15th of April, because this is a very fast moving area and it can change. Firstly, how does the body defend itself against the virus? Well, we have a lot of things in our immune system that are designed to recognize and deal with these sort of external threats. But initially, most of these in our body really won't recognize the COVID virus. They're sort of set up to deal with things that we've seen in the past. So this is a bit of a problem for our initial reaction to the virus. However, the good news is that there will be some components of that immune system that are set up to deal with and recognize that virus. And so that gets our immune system thinking, what can it do about this and how can it amplify this response? And it does amplify this response because the binding of that antibody to the virus, combined with the SOS signals coming from the cells that are infected throughout our body, together result in a ramping up of the production of these antibodies specifically targeting the COVID virus. And now we've got lots and lots of them mobilized in our body, mass produced in a way that we can hopefully deal with the virus. And so that's a good thing that our immune system is doing. Now there should be enough of this antibody to start mopping up all of these viruses and resulting in their destruction, and thus protecting us from the virus. The trouble is that this sounds like good news, but the trouble is that this takes several days to develop, and in that time, the virus can be doing a lot of harm and could even have killed people. So ideally, we need something that would stop the infection in the first place, and that's where a vaccine comes in. So a vaccine is made by taking bits of the virus and injecting it into our bodies well in advance of the time we would be infected. And this primes our body to make lots of these antibodies to be sitting around like an army, ready to attack the virus as soon as it might wander into our body, therefore stopping it from dividing and getting out of hand in our body. And this is a well-known concept. It's something that we do all the time with vaccines to all sorts of other diseases. And of course, it's the hope that we can develop a really good vaccine for COVID as well. The good news is that many groups all around the world are using all sorts of different strategies to try and develop vaccines to COVID-19. The bad news, though, is that developing a vaccine isn't quick, and it'll be many months, if not over a year, before such a vaccine is likely to emerge. So until there is a vaccine, what can we do? The main thing we can do, of course, is not to catch the disease in the first place. And the best way to ensure that is to follow all the guidelines that we're getting so used to now. That includes washing your hands, that includes staying home if you're sick, that includes social distancing, all of those things that we know so well now. But if people do get COVID, are there things that we can do about it? Well, one possibility that's being looked into is using the antibodies from people who have already recovered from COVID. Presumably, these people have made lots of antibodies in their serum, and so basically this is the same thing as a blood transfusion, which is being proposed to transfer those antibodies from the person who's had the disease into people who might be sick. Let's see if that works. It's currently being investigated in many places. Of course, another possibility is the possibility of using drugs to treat COVID-19. Drugs can be manufactured quickly in factories and so potentially be a much quicker and easier way than a vaccine in theory. Drugs have been developed for other types of viruses and are widely used, for example, for cold sore treatment, to treat HIV, to treat things like hepatitis B and so on. So it can be done in theory. So far, no drugs have been proven to work extremely well on COVID-19, but there are a couple of types of drugs that might work and are being looked at. But it's important to realize that these haven't been optimized yet. Here is a summary of some of the main things that are being looked at the moment. Firstly, a lot of antiviral drugs that are being developed try to stop new copies of the virus being made. In the last video, we talked about that machinery inside the cell being hacked by the virus to produce new copies of the virus using the genetic information from the virus. And this is indeed going on all the time with these viruses. So a lot of the antiviral drugs are really aimed at targeting this process here of blocking that information coming from the virus's genetic information and specifically targeting that. And the advantage of this is that these drugs can target just the virus and not having any damaging effects on our own human cells, hopefully. There are a number of drugs you might see in the press being referred to, remdesivir and favipiravir, tongue-twisting names, but they are two of the most talked about at the moment with potentially the most promising results. But we'll just have to wait and see. There are other wildcard drugs being talked about that could potentially work and are being looked at, such as indomethacin and ivermectin and many others. But it's too early to tell as of today. But there are at least 200 trials going on, including some being planned and developed here in New Zealand. So another way to potentially stop the virus is to stop it getting into the cell. We know from the previous presentation that the virus has to bind to something called ACE2 to get into the cell and unpack itself, and this is critical for its reproduction. What if we could stop the virus getting into the cell? Well, there are drugs that look to do this. One of these is the type of drug called chloroquine or hydroxychloroquine that Donald Trump talks about. And in theory, this is a drug that could block the virus getting into the cell. But it really does have a lot of side effects on normal functions of our cells and can be toxic. Plus, there have been a few trials already reporting results, and it really just doesn't look like this works for COVID-19. But, let's always try and keep an open mind. So what about the possibility of targeting ACE2 directly? So in this context, ACE2 is not a sequel to a well-known movie about pet detectives, but in fact a protein sticking out from the surface of many of our cells that has a very big role in regulating blood pressure. Just by unfortunate chance, it was also the receptor for the COVID virus. A lot is known about ACE2. It's been a major study of its actions to understand how it regulates blood pressure, and this has resulted in many drugs that are able to lower blood pressure. These include drugs called ACE inhibitors and ACE receptor blockers. So what about using these? Well, this has been the subject of a lot of interest recently, and there is some preliminary evidence suggesting that maybe they do indeed have a positive effect, or some of them may have a positive effect on outcomes of COVID infection. But it's really, again, too early to tell, but it'll be a very interesting area to watch for the future. Another type of drug you'll see referred to doesn't target the actual virus itself, but targets our own immune system. Our immune system has to be working just right to fight a virus. Not enough response is a bit like Goldilocks' porridge being too cold. And too much response can damage our own immune system. So the response has to be just right. And in some people, the immune response gets hyperactivated by all these emergency signals coming from the infected cells. And this can really cause more damage than the good it does. And this needs to be countered. So there are drugs that can handle this, and these drugs block that immune response, or block that thing called the cytokine storm, you'll see it called, and dampen that down and hopefully return the immune system back to normal. You can imagine it a bit being like a serious allergic reaction, and I think many of you will understand that a severe allergic reaction can kill people if it's not treated with antihistamines. And it's a parallel to that, a different mechanism, but you can imagine it like that. So a lot of people have also been asking about the testing protocols and how they work and the limitations of those, etc. One of the questions is, why do we use a swab down the throat, and why don't we just do a blood test like we do for so many other things? Well, in the early stages of the infection with this virus, it's mainly infecting the cells of our nose, throat, and airways, and not really detectable that much in our blood. So we really need to take the material from our throat and so on if we're going to do that, and that means we've got to stick something down there and a sample down our throat. Another question is about the type of tests that we're using and their reliability and the speed of doing these tests. Well, the best way to do this test is to look for the genetic material that is unique to the COVID virus, because by doing that we can make sure we really do have the COVID virus and not some other type of virus. This first relies on us actually getting some of that genetic material onto that swab and then purifying out that genetic material from that swab that's been taken, and then doing a couple of steps to that material and then analyzing it on something called a real-time PCR machine. So this is quite an expensive process relatively and requires this very expensive machine. So this is why the samples have to be sent to these centralized labs, and the whole process takes about a day. So it is, however, the best way of detecting the virus early in the infection cycle of people, and that's why we use this PCR test. What about this rapid antibody test that we see talked about in the media? It is true that eventually we will be able to detect the antibodies to COVID-19 in our blood. But remember, from what I just said before, this can take quite a few days for these antibodies to show up. So this is really ineffective for detecting people quickly. So we want to detect people as soon as possible so that we know that they're infected and we can stop them from transmitting that infection to others. And this PCR test to detect the viral genetic material can detect the virus in our bodies much sooner, much earlier in the infection cycle. So for what we need to do now, it's a much better test. Eventually, we will use the antibody tests, I'm sure, to identify how many people overall have been affected by it, and also to understand how much immunity people have to this virus. But the priority at the moment is doing the PCR-based testing for the genetic material of the virus. So finally, please be rest assured also that 5G does not cause coronavirus, so please don't burn down the mobile phone towers, as we need them to stay in touch with each other during this lockdown. That would be really helpful. Finally, remember that there is a lot of light at the end of the tunnel and lots of light shining in the sides of the tunnel as we go, and that we're learning a lot about this virus and how to combat it. I hope you found that useful, and I'll try and do some more updates in the next week or so.